So hi everyone, my name is Davis Vaughan. I work at Posit as a software engineer. I work on Positron, I work on the R side of Positron. I also do a lot of tidyverse stuff, so I work on dplyr, tidyr, a number of the big R packages that we put out at Posit. And yeah, I'm here today to talk about like existential crisis. Like I've heard around the grapevine that like a lot of college students are just like really worried about like their degree, like upcoming jobs, things that are going to be waiting for them in this age of AI. Will I even have fun at work anymore, or is AI just going to do everything for me? In my opinion, like to be able to answer this question, like I thought I needed a graph, and on this graph are two types of work. We'll refer back to this quite a few times. On one side, we have what I deem micro work, which is this idea of like these small things that you're doing, small bugs, refactors, tedium, work that like certainly needs to be done if you're a data scientist or a software engineer, but it's not really like big picture ideas. On the other side is this macro work. This is the idea of like code architecture, like the really big ideas of how a system is supposed to work. Managing complexity, like being able to take a step back after you've hit the same bug or issue like 6 times in a row and saying like, should we try to simplify some stuff? Like, is something wrong here? And then if you're like going into data science, this idea of translating code to actual business decisions lives on this side of the spectrum. So I kind of think that, there are people that live on either side of this spectrum. Like if you're kind of a junior developer or in a junior developer mindset, even with AI, I think you can only get so far. Like you get somewhere into this micro range, you can do these tasks, maybe AI can help you do them better than you could by themselves, but you can still only get so far. By counterpoint, like I think a senior developer can get pretty far into macro even without AI, but then they are able to use things like Claude Code or Codex, which we'll talk about today, in a way that makes them even able to do these macro tasks a little bit better, which I think is pretty interesting. And the big difference that I see, like the gap between like what makes junior developer versus senior developer more effective with these tools, is that I think a senior developer is really good at the fundamentals. Like they have a foundational knowledge of programming. They have the ability to say like, I think that smells wrong. Like that just doesn't feel right to me. They have the ability to critical think. And I think that's just like really hard to get if you're just letting the AI do all the work for you. Now, the reason I think your degree is not worthless is because I think it falls into this fundamentals category. This idea of like building up foundational knowledge of how to critical think, how to learn, how to lay the foundations of what programming is and build some intuition around the systems that you're building is kind of all wrapped up in like a computer science or even data science degree. So in this talk, we're going to kind of just answer 2 questions. How do you learn the fundamentals of programming in 2026? And then why on earth would you even want to? Like, it is 2026. Isn't AI supposed to be just doing everything for us? Like, what is the point of learning the fundamentals these days? To start with the first question of how you learn them, we're going to start by looking at dplyr. How many of you have used dplyr before? Yeah, great, yes. Thank you for keeping me in a job. So recently we released dplyr 1.2. This was a big release, and it came with a number of new functions. If you were studying or if you use dplyr on a regular basis, you might want to kind of keep up to date with your fundamentals of how this thing works. Like that allows you to do future work or even talk to an AI and kind of guide it to use some of these new tools that we've created and use all these best practices. As an example, like we've released this new function called recode values, which is really cool. It kind of lets you map values from kind of one state to another. And if you were to learn if you wanted to learn how to do this, typically you might, read the blog post, read the documentation. And I think all of that is great. I mean, I certainly spent a lot of time working on them. So if you read them, I appreciate it. But it is 2026. So like more likely you're going to turn to something like Claude Code and say, hi Claude, I see that dplyr 1.2 has added this new function called recode values. And instead of just saying, can you tell me what this is, I think there's like some more interesting ways that you could talk to Claude to learn how to use tools like this. You can say, I actually learn best by example. So can you write some examples into an R file for me called recode values? And by the way, like I actually learn best when you use my data with those examples. So I have this flight CSV that you could maybe go ahead and read that. I think that's okay, like it's allowed. And then we're going to generate some examples that are tailored to my specific data source. So if we take that and we go over into Positron, this is what Positron looks like. It is a fork of VS Code, so if you've used VS Code, it should kind of feel vaguely familiar. And in Positron, I've got like a terminal session open on the right with Claude running inside of it. How many of you have used like Claude Code or Codex or something like that before? Okay. How many of you have used like ChatGPT before? More basic, yeah. Okay, great. One major point of this talk is that I think if you're going into like a data science or software engineering field, I think it's time to start looking into kind of this agent-driven workflow that Claude Code or Codex kind of provides. Because they are just like way more powerful and a totally different beast than talking to a chatbot. So let's see kind of what happens. So over here, I've pasted in the prompt of like what we were just talking about before with Claude Code, and it starts to think for a second. And because I'm in this kind of repo here with recode values as a folder, it actually can look around and find flight CSV that I referred to inside of the recode values folder. It starts to read that thing to gain some intuition about what kind of examples it should start to build for me. It thinks for a little while, and actually it outputs something kind of interesting, and I didn't know it was going to do this, but I decided to keep it in. It says, I have no idea what this function is. And that's because these models are trained on data at a snapshot in time. And even though this was only me doing this like a week ago, like this model was trained up to May 2025. And this is, the most recent Anthropic model at the time, like Opus 4.5, I think. So that sucks. But it's not the end of the world. Like these things are pretty cool. Like Claude Code allows you to just paste in a link to some documentation. It can go out, read that documentation for you, and then kind of continue on its way. So this is a link straight to our dplyr documentation about recode and replace values. Haha, see, my work did get used. So it thinks for a second, and after a minute, it will actually write an actual file to disk for you. Again, this is something completely new if you've never used Claude Code or Codex before. ChatGPT isn't going to be doing this for you. It can write to disk a new file on your behalf because I've given it permissions to do so. And then things get really interesting. Because you're using Positron, which has a built-in console and can run R code or Python code just interactively, you could just start stepping through this code one line at a time. And as you're doing this, you're using these examples generated with your data to very quickly learn how this new function works. You can gain some intuition on how you're mapping from UA to the actual United Airlines airline here, and you can see how that kind of appears over in carrier name over on the right-hand side. You can learn how to use this function with lookup tables. You get to learn about all the new arguments that we've included and all the kind of important things that you might need to know to build some foundational knowledge of how to use this in day-to-day work. And I think the important point here is that in 2026, it's never been easier to just surface knowledge about things that you're interested in. And that's so valuable. This was buried in blog posts, this was buried in documentation. If you missed it, it's kind of maybe hard to go back and find it. Claude just kind of seems to know, especially as it gets retrained past May 2025 and can pick this stuff up. If you don't pay for Claude Code or Codex, I still think there are some good options for you. DeepWiki is just a website that's out there that we all at Posit kind of find pretty interesting because it's kind of indexed all of GitHub. You can go through and just search for dplyr, which lives on GitHub, and then you can kind of interrogate DeepWiki about dplyr. You can just say, tell me how to use this new function called recode values. And it is up to date enough, and it can summarize and say, here is one way to use this function using the formula API. Here's another way to use this function using the lookup table API. Again, you gather all of the necessary context very quickly to learn how to use these functions. Can't necessarily run code like you did in Positron, but you could copy this example out very quickly and take it over. I just think this is so cool as a way to like amplify the learning that you were already doing, and just make it happen a lot faster and a lot, honestly, deeper of a level at some point if you actually spend some time looking at what these tools output. And I don't think we're necessarily alone in trying to use these tools to learn new things. There's a psychological scientist that works in the tech space. Her name is Kat Hicks, and she has created what's known as a Claude Code skill. A skill is kind of like an extra plugin that teaches Claude Code something new that it didn't know how to do before. Her skill is called learning opportunities. And the way that it generally works is that as you're sitting there talking back and forth with Claude Code, it can kind of pick up on the fact that you're asking it a whole bunch of questions about something. So when it picks up on the fact that I've been asking a whole bunch of questions about recode values, it says, hey, would you like to do a little quiz on this thing? And if you say yes, it can output some code of what recode values is supposed to do, or output some code and kind of question you about what you think recode values is supposed to do in this case. It gives you a little prompt at the bottom where you can input your answer. And in this particular case, I got it right. It says, yeah, that's correct. Here's why I asked you this question. I kind of wanted you to learn a little bit about how it treats unmatched values. If you get it wrong, learning opportunities kind of gives you the answer, but also gives you, again, some explanation about what it was trying to teach you with this particular example. In this case, it was trying to help you learn the difference between recode values and replace values, two very similar but functions we added in dplyr, but have very different purposes. So, in 2026, you have so many tools available to you. It's never been cheaper to have your own personal tutor. I was talking to Mine about this earlier, and the Duke tutoring business is suffering a little bit, and I think a lot of it is probably because tools like this are so good now at teaching people things that are specialized to their exact use case. But I think you can use that to your advantage as well. And when I say cheaper, what do I mean? Well, if you want access to Claude Code and you don't have access to anyone who pays for it for you, you at least need a Claude Pro account. This is $20 a month. It gives you, based on my understanding, some weekly allotment of tokens. If you use it really heavily, though, you will burn through this in 2 or 3 days out of the week. Claude Max, on the other hand, is more expensive at $100 a month, but it's likely enough for you to not get rate limited by anything that you're going to be doing. But if you break it apart and you say, how much could I be paying for tutoring in any given month, right? Maybe you'll still come out ahead with something like Claude Max if you just use that for tutoring instead. And hey, now you've also got this AI agent you can use for anything else in the meantime. I have one colleague at Posit, Michael Chow. He is learning Cantonese using Claude Code, which he said is particularly good because Cantonese is not typically a written language, but there is a way to do it, but not many people know how, but Claude knows how. So he will have it listen to some Cantonese and then transcribe it to text for him to learn how to write Cantonese, which is a very interesting, neat use case that I think is pretty cool. And of course, here this line at the bottom ends up being pretty important. Posit for me pays for kind of an unlimited Claude Code account for me. I don't ever have to think about tokens unless I really want to. And I think that for Posit, it's definitely a net win, the amount of time that we save using these tools versus what they end up paying for them is just an absolute net positive at this point in time. I have heard about Duke GPT. I don't think it's quite going to be the same as something like Claude Code or Codex from what I've heard, but it's at least a way to get your feet wet with these tools. In addition to being a really good tutor, I think these tools can also be a really good TA. And by that, I mean a way to check the work or check the code that you're writing. And I don't think that this kind of thing is just useful for students. I use it as kind of a personal TA almost every day. there is another Claude Code skill or plugin called PR Review Toolkit. And when you call this thing, it looks at the feature that you've been working on. For example, in my case, I was adding a progress bar support across 6 different Git commits. And it kind of figures that out on its own by comparing the branch I'm on versus the main branch. And it says, okay, I'm going to look at those 6 commits on your behalf, and I'm going to decide what kind of review agents seem most useful here. Here it picks 3 different types. A general code review, one specifically about the error handling in this feature, and one specifically to look for ways to simplify the code. It launches all 3 of those in the background. We wait for a little while, and eventually it aggregates that information that comes back from each of those 3 in a nice summary. And it tells you ways that you can improve your code. It says, hey, you missed some documentation about this particular thing. You have a typo in one place. You missed adding tests for one of these features. And by the way, like at the top, here's some critical issues. It's a little scarier than it actually is. That says, the old code used to do it a certain way. Your new code does it a different way. You should probably at least think about this before you kind of continue on. And I think this can be really useful for both you and me. Like for you, you could do this as a way to maybe check your code before you turn it in, as long as your teachers have kind of agreed that that's fine. But for me, when I write features and pull requests, there's typically going to be another human on the other side reviewing these features, right? And if I can get all of the grunt work out of the way before I turn it over to the other human, that is less work for them to have to do on the other side. And it means that they can focus on, the big overarching idea of, is this adding a progress bar in this way even a good idea? So, again, 2026, you have tools for being a tutor, you have tools for being a TA, you have so many things at your disposal to kind of learn these fundamentals and get better and better at writing code. But I would argue that none of them are as important as learning Git, which is your AI agent's best friend. And the reason for this is captured very nicely in this little before and after of our recode values example before. I have made some changes here. If I were to ask you what I did and like have some high degree of confidence that you've caught all of the changes that I made, it would be very hard for you to do so very quickly. On the other hand, if you use version control or Git, you can very quickly see that I've made 2 changes. I took the S out of flights, and I changed the way that Delta Airlines is spelled. The reason that I think this is so important is twofold. When Claude makes changes on your behalf to your code, you need to be able to look at it and say, what the heck did it do? Without version control, that's effectively impossible. On the other hand, if you're using something like PR Review Toolkit to get a review of your code, Claude needs to be able to look at your code and say, what the heck did you do? And there's no way for it to do that without version control. Again, you saw before that it looked at the last 6 commits. Underneath the hood, it was using Git. So you need to have some kind of foundational knowledge of how to use this tool as well, which again will kind of benefit you later as well, because this is the lingua franca of how people work in the software engineering world. I don't just work with Claude using Git, I also work with other humans using Git. It's also an example that's kind of not listed here is the fact that when you are working with these tools like Claude Code or Codex and you're asking it to make changes on your behalf, 30% of the time it will go completely off the rails and do something that you had absolutely no intention of wanting. And you need some way to just quickly undo all of that work, right? And Git gives you a way to just discard all of the changes that it's made. So this is a little bit about like what are the fundamentals, how do you learn them in 2026? But we still haven't discussed the why. Why do I even care to still learn these new tools, or to still learn the fundamentals? If we go back to the beginning, I would argue that the reason is just captured in this little difference between a junior and a senior developer. And there's a big mindset shift, especially in how you talk to these AI agents in between when you're a junior versus when you're a senior. You see, kind of my big opinion here is that juniors do a lot of asking. They go to their AI agent and they say something like, or they go to ChatGPT and say, I'm not really sure how to solve this problem. I don't know how to solve this bug. Can you help me get started? Or can you just do it for me? Like, I don't really care what the solution looks like. Can you just do it for me? Seniors, on the other hand, will do a lot of what I call directing. They know exactly what the solution is going to look like at the end of the day. And they say, you should use this library. Here's roughly where the change is going to happen. Here's how you should kind of implement it. Here are the tests I'm expecting. By the way, don't forget to add a news bullet. And here's like a 5-bulleted list of things that your little agent is going to go off and do. And that is going to produce something that has a much higher level of rigor than just saying, can you just fix this for me? Or can you help me with this problem? Now, I don't think that this junior level mindset is bad by any means. I think that asking provides a lot of momentum on how to get started on a problem when you have absolutely no idea what to do. I just think that in the end, if you're shooting for the highest level of quality, you end up switching at some point to this kind of directing mentality instead. So we're going to go through some examples of both the asking mindset and show you why that's useful, and the directing mindset and show you why that's useful. And hopefully that'll kind of give you some idea of both and why it's useful to be able to switch into this directing mindset and why you need the fundamentals to be able to do so. So for the asking mindset, we're going to start with this kind of modeling example. This is just a basic linear model in R. There's nothing fancy going on here. That's not the point of this example. We're going to use this Ames data set. It's just a whole bunch of sale prices of houses. There's a number of features that come in this data set that we've just kind of pre-selected in blue. Nothing fancy. But say that you're like, this linear model's cool, but in school you also learned about random forests, and maybe you've got a pretty good, solid understanding of how random forests work, at least at a theoretical level, and you want to switch and kind of implement this in R and switch from linear model to random forest. But you've never actually written one in R before. You don't necessarily know what all the code for this is for. But you have kind of done a little bit of Google searching, and you know that this thing called tidy models exists as a framework out there. They surely have support for random forests, so we're going to see if we can use that. At the same time, you've maybe also heard of this thing called Positron Assistant. This is very much like Codex, except it's kind of native, or Codex or Claude Code, except it's natively integrated into Positron as a tab here. You can talk to it, and it can do everything that Claude Code can do, and a bit more in the fact that it can actually see your live R or Python session at the same time, which ends up being pretty powerful. It can see Star Wars. It can see all of the column names. It can execute code on your behalf, and it can even see your plots. So you might go into Positron Assistant and say, hey, I know about this thing called tidy models. I found that this package called parsnip seems to do model fitting. Can you write a random forest using the model that I already had and kind of translating it into random forest instead? Positron Assistant says, sure, here you go. You execute this, and you're pretty happy to see, sure enough, it executes and outputs a random forest model. I'm assuming you have the theoretical foundations to be able to interpret this thing the right way. Otherwise, things get a bit dangerous in how you're doing the statistical work. But assuming that you can, and that you just needed some help with the code, this is pretty useful. Taking it one step further, you might say, well, I know about resampling as well. I'd like to actually add some bootstrapped resampling into this too. Again, you've done a little bit of tidy models work, or tidy models research. Maybe you know this package called rsample can help you with bootstrapped resampling. Give it a fairly useful prompt here, and it outputs this other bit of code. You might not know what this does, but you execute it, you kind of get a glimpse of what it's supposed to be doing, and it says, okay, here's a root mean squared error, bootstrapped over 10 samples, here's the mean value. R squared, bootstrapped over 10 resamples, here's the value. You might be pretty impressed. I was pretty impressed that it kind of got this in the first one shot. But then you might take it one final step further and say, okay, great, that's cool. But how far could we go? What if we wanted a Shiny app and we wanted to rerun this thing various times? Because I know about this hyperparameter to random forest when I was studying called trees, and this kind of controls the complexity of the random forest and how many decisions it can kind of make. And then I want, maybe I want to vary that a little bit to see if that affects the performance of the model. And I want a Shiny app to do so. So I take this kind of exact prompt, and I go over into Positron Assistant, and I'll hit go here. And Positron Assistant thinks for a little bit, and it starts to output a Shiny app in this block of code here. It's really well integrated inside of Positron so that you can go up, you can just hit play, it will execute that code in the console, and again, because Shiny is very closely integrated in Positron itself, it can just pop that open in the viewer. You can drag around the number of trees here, hit fit model, and eventually it kind of pops out this table at the bottom that you had before. You could drag around, hit fit model again, wait a couple seconds, and it'll pop back out. And this is obviously a very basic example, but I think this is very cool that like Shiny apps, which I am not a Shiny developer, are now super cheap and easy to write, and like very easy to just have throwaway Shiny apps. Like that's really cool. Maybe you need to prove out like a meeting or prove out a proof of concept for a meeting. Like maybe you need to iterate on an idea and you decide that it might be best to just kind of do this visually so I can get a quick re-render a graph like 7 different ways and use like a Shiny app to do that. No matter what you're doing, I think this is really quite neat. Or, you might take it one step further and say, this is definitely a production level Shiny app, so I'm going to take this and have it be written to an app.r file for me. All this does is just like write the actual Shiny app to a file, and then you can use this to maybe reproduce that Shiny app at some point in the future. You end up with some reproducible artifact at the end of your conversation with Positron Assistant, which I think is really, really valuable. You could even combine some of the things that we've talked about before. You could go into learning opportunities, fire up that skill, and say, now I actually am interested in learning a little bit about Shiny, so can you quiz me on the Shiny code that is used inside of the Shiny app? It could start to ask you questions of like, how does sidebar panel work? I don't know. How does an action button work? I don't know. But learning opportunities can probably figure it out and give you some good help you build intuition on how Shiny works in this particular example if you are interested in learning more. So, at Posit, we've been thinking a lot, like what does AI-empowered data science look like? And I do think this is kind of on the right track. It might not be exactly, it's certainly not going to be exactly where we land in a year or two's time, but I think this is going in the right direction, where this can do more than Claude Code or Codex can do because it's more tightly integrated with your session. It knows what packages you have installed, it knows all the variables, all their column names, how to use them, it can see your plots, it can execute code on your behalf. And all of this is optional. Like some people get very scared by this and the fact that, for good reason, they might work in HIPAA compliant areas where, you can't just put patient data through an Anthropic server and have it come back. That's not a great idea. But assuming that you can share these things a little bit more widely, this ends up having very powerful and profound impacts on how you could do your work. So all of that in my head is kind of like the asking workflow. Like we got valuable things out of that, but we didn't necessarily go in knowing exactly what we wanted or exactly what it was going to look like. So we just kind of took whatever the AI was giving us. On the other side is this directing workflow, where I would argue you really need the fundamentals of programming to know how to even do this the right way, in a way that's producing high quality, effective work. For that example, we're going to go over to this, which is something called Syntax Lite. I stumbled across this in a blog post like a week or two ago, and I thought it was really, really interesting. So this person at Google works in an area that has them dealing with a lot of SQL all the time. And they were a little bit frustrated with the fact that for their, they were just using SQLite, a fairly common, like the most common probably flavor of SQL that you could use. And they were frustrated by the fact that they didn't have good developer tooling. They didn't have like a formatter where it took, their ugly SQL code and produced some really pretty SQL code on the right. They didn't have anything that produced diagnostics when they typed in something wrong. So they worked on building one. And they were able to build something kind of that you see here, where, as you're typing here, it's reformatting over on the right-hand side, automatically like formatted SQL code. And then you see the squiggle at the top middle. Here I've made a typo. I click on that, kind of hover, and it says, oh, it looks like you've typed the wrong name of something in your database, like it looks like it's probably supposed to be quantity. Would you like to change that instead? You can hit quick fix, accept, and it will update to quantity. And this tool is cool, but I think the story behind how it was built is even cooler. You see, this person spent about a month vibe implementing a version of this tool and letting Claude handle all of the implementation details, all of the decisions. It just kind of gave it some very high level details of what it was supposed to do. And from a purely technical perspective, it kind of worked. It could parse and reformat SQL and do kind of the things that they wanted it to do. But then the senior engineer at Google kind of took a peek under the hood and looked at all the code, and it was just a mess. It was things that would never land inside of kind of a production Google environment, which was where they wanted to take this eventually. It was not structured in any meaningful way. It was fragile. It only did precisely what they asked it for, but then they changed anything a little bit, and it just kind of fell apart. So, when I read this, I was like, oh, it's a bit like this. This is an old meme from a number of years ago where it was here's what I want, here's what I got, right? And that felt very accurate in this case. So this person stepped back, and again, senior engineer at Google has used these kind of tools quite a bit. Took a step back, and he said, okay, we're going to do a different approach. We're going to go feature by feature, and very carefully in a tightly integrated loop work on one feature at a time, where he would say, Claude, I want you to work on Hulk's eyes. That's all we're going to work on right now. It would give a first pass, he would refine, talk back and forth, maybe get in there and change some stuff himself, and really get some tests integrated and all that kind of stuff to make sure that the eyes look great. He would move on to the 3 and work on that feature. And he found by the end of this kind of experiment, it took him 2 months instead of 1 month of vibe coding, he had the product that you saw on the previous couple slides, something that he felt pretty confident about. He also discussed how he felt more connected to the actual code. He actually understood what was going on under the hood because he was very tightly integrated in the process of building the thing. And I wanted to share a couple other quotes from the blog posts that I found particularly relevant. While I was working on something that I already understood deeply, AI was excellent. I could review its output instantly, catch mistakes before they landed, and move at a pace that I would have never managed by myself. And this certainly sounds like a resounding endorsement of AI, but I actually think there's a couple pieces of this that are doing the heavy lifting. I already understood the part deeply. This implies a level of foundational knowledge that this person had to be able to say, I know exactly what this is supposed to do. So when you give me the output, I can say yes or no, that's a horrible idea. We're not going that way. That's not what I expected. This person could build this thing themselves. Claude just helped them do it faster. The second is this bit in the middle. I could review its output instantly, catch mistakes before they landed. And this implies some level of engagement required to do the high quality work. They're not just, giving a big prompt, stepping back, coming back a couple hours later and seeing what the output was. It was no, every 30 seconds they would jump back in and start working on it, reviewing the code, send off a small prompt, it would come back, they'd work on it a little bit more. This was a very tightly integrated loop, and I have found that this is a very, very effective way to work with Claude. And this way of working just feels so far from this almost meme-ish idea of vibe coding these days. People have coined this ulterior term of agentic engineering, and that just feels like a very fancy word. And at some point, if you do get in there deep enough and you are working back and forth with this system, it's just engineering. You're just doing good software engineering at some point. And really, I feel this person is just squarely here in this idea of being a good senior developer, doing big macro level work, creating an entirely new product, and doing that using Claude, using AI. He also discussed one point where he felt kind of out of his depth, which I thought was pretty interesting. He said, when I was working on something where I really didn't know what I wanted, AI was somewhere between unhelpful and harmful, and we kind of discussed that with the Hulk slide. The architecture of the project was clearest case. I spent weeks following AI down rabbit holes, like exploring designs that felt productive in the moment, but then collapsed under scrutiny. They were more fragile than they kind of appeared at first glance. And to me, like, if you think about our graph, like, this feels like a junior developer mindset trying to extrapolate to macro level work without the fundamentals in between that can help them decide, like, when things are good or bad. They're trying to rely on the AI to do all of the work for them, and it's just straight up bad at design work sometimes. It's good at the micro stuff, bad at the big macro stuff. And what's still kind of implicit in this statement is that, again, this person is a senior level engineer, even though they were taking this kind of junior level mindset of just like asking it to do all the work for them. What this person knows is that work was sloppy. They are able to see the result and say, like, no, that is still bad code, bad Claude. Like, you did not do very well here. So I would caution you all, like, when you are, doing work on your own, moving into entry-level positions, to avoid trying to take on macro-level tasks that are kind of out of reach of things that you can review, you can understand, and like, it's just too easy to allow the AI to make these large decisions for you, and then you find yourself without any real understanding of the actual code and the project under the hood. If you do this, and you ignore all of my advice, I think that you are very likely to end up like Mickey from the Sorcerer's Apprentice. I don't know if any of you have ever watched Fantasia and the Sorcerer's Apprentice, but if you haven't seen this, I think it's like weirdly accurate for this exact scenario. You see, Mickey is trying to learn to be a sorcerer. So he goes to the sorcerer and he says, I want to learn magic. And the sorcerer says, okay, I'll take you on as my apprentice. But first you have to do all this kind of menial labor to learn the fundamentals, right? So Mickey is carrying buckets back and forth to the castle. And it's buckets filled with water. He's tasked with filling up this well, and he's tired. And he doesn't want to do this. He wants to learn magic, darn it. He doesn't want to carry buckets of water back and forth. So he finds the sorcerer's hat. And this is the source of all magic. And he learns this spell that he could use using the sorcerer's hat, and he activates this broom who can carry these buckets of water back and forth on his behalf. Things are going great. He doesn't necessarily understand how this spell worked. He doesn't understand really anything about it, but it worked. Except did it? Instead, things kind of get a little out of control. Like, the brooms multiply for reasons that Mickey does not understand, and now all of a sudden we have thousands of buckets of water being brought into the castle at a really rapid rate. We end up flooding the castle, and Mickey is, waking up at 3 a.m. because his boss called him and said, the system's down, like, what's going on? And he has no idea what's going on. He's reading the documentation of the system, trying to figure out what Claude has done the Magic Hat has done on his behalf. And he's really struggling here. Finally, the senior sorcerer has to step in. And what I think is interesting is that the senior is probably still using Claude. He's still using the Magic Hat, except he knows the fundamentals. Like, he can cut through the mess and say, this is where things have gone wrong. I have a good intuition about how this works. I understand the system. I understand the project. I understand the code. And I can see where the problem lies and clean up the mess pretty quickly. This example is obviously a bit silly, but I do think it kind of paints the correct picture. This idea of, like, you can get by with AI, with just AI for quite a while, but eventually I think you will hit something that you can't AI your way out of. And at that point, you will be pretty happy that you didn't skip out on the fundamentals. So I'll finish with a little bit of practical advice. Obviously, I want you to learn the fundamentals to become a better programmer. But I also think it will help you stand out, like in hiring interviews. We talked to a customer of Posit recently, and they were talking to us about their most recent round of hiring interviews. They said they were the worst ones they've ever seen yet. And it was because people have come in and just been relying too much on these AI systems to do all of the work for them, and then they get presented with a complex enough task and they just fall apart. So I think like how much can you stand out if you know both like the solid fundamentals of programming or data science or statistics, plus you have the ability to kind of direct these systems to do some of that work on your behalf, rather than being like your peers where you're just asking them to do all of the work for you. We talked a lot about Git and how I really think it is quite an important thing still in 2026. Your AI will thank you, but also your colleagues will as well, because it is the way that you actually talk to them back and forth on a day-to-day basis. Again, you come to a hiring interview and you say, no, I have a good understanding of Git and how people use GitHub, and I think that gives you a leg up over a lot of other people when you're trying to get hired. I really do think it's time, people. You have to learn these tools like Claude Code and Codex. Like, these are going to be some kind of industry standard. For me, the moment was like December of this past year. Like, they released Opus 4.5, and I finally looked at it and said, it's good enough to get some real work done with. And I think it's just only going to get better. But lastly, like, I just want to leave you with the idea that it's still fun. Like, I certainly had a mental health crisis of like, am I even going to like the work that I'm doing anymore? Like, I really liked getting in there, doing the nitty-gritty work of programming, creating something really cool, because it was blood, sweat, and tears to get it done. And I still feel like I get to do that, except a lot of the menial labor can just be kind of, shunted off to AI these days. I still feel like I get to do fun, meaningful, impactful software engineering work. And if I can, I think you can too. And that's all I have. Thank you very much.
Anyone has any questions for Davis? If not, I have a couple. So I know like Codex just came out. Have you used it?
Hold on just a second.
Okay.
The worst thing that I could do is lose a 45-minute recording.
Oh.
Okay. Yeah. So I have not personally used Codex, but JJ, our president, has used all of these tools, and his opinion is that Codex is actually the best at code review. This idea of like PR review toolkit, where you use an agent to actually review your code first. He says he will not look at a human review. He will not do a human review before Codex has reviewed it first and taken out all of the kind of menial work first. So, like as Hadley says, when JJ says something, we listen. So like if JJ has endorsed to Codex in terms of like being a good code reviewer, I think there's something there.
Okay.
Yeah.
Yeah, and I was also wondering, like, because I think a big part of the worry is that when you're getting into the industry, you're going to be a junior dev.
Yeah.
And the worry is that what if the senior devs just use these systems to do the menial labor that you would have come in and like done on your like internship or in your first however many months in the position? Like, do you think that'll happen?
Yeah, I think there will be companies where that happens in. I think that like companies are going to have to look in the mirror and say like, we need to train up the junior engineers. We have to let them do some of this work because learning hands-on is how they learn. I also think there will probably be other things to do. I can't quite explain this yet, but like the menial work maybe goes away and the junior engineers get to learn and train on other things instead, like things that are just like meaningful but smaller projects instead of just doing like menial work of refactoring and fixing the tiniest little bug and stuff. I can't quite explain that yet, but like we don't really know what the future looks like yet. So, but as of right now, Posit is still hiring interns. Like we're still like doing internship programs to do like smaller package work and stuff like that. So we still think it's impactful to kind of train up this next generation. It is obviously a big question on everyone's mind though, right? Like if we just don't hire entry-level people anymore, like how will we get senior-level people in the next 10 years? Like we will have this massive gap, right? So that will work itself out, I think. Like I don't have the answer of how, but I think maybe the gap will be filled with people doing slightly different work than what a typical entry-level person would have been doing.
I see. So I mean, but like presumably at some point maybe these systems get better and better.
Yeah.
And like truly you can, for instance, just have even someone junior come in and be able to do the asking around. And like
Yeah.
Maybe it's just good enough to get you something.
Yeah.
That
I think today it's good enough to get a lot of that
right.
something. Yes. But again, like eventually there will be a point where it can't do the something, right? And at that point, what do? Do you just go talk to your boss and be like, I can't do the something? And it's like, well, it's because you didn't learn the piece underneath, right? I don't think it will be, I think it will always, well, I'm never going to say always with these systems. But as of right now, it is very bad at like the macro stuff, right? It's bad at the design. It's bad at like making something that users really want to use, things that feel good. Like I think dplyr is so successful because it was very thought out in terms of how the verbs work and like how things connect together. I think the overarching design has a lot of human element in it. And that stuff is still like hard for it to do. So there will always be things there.
Where do you find the edges of what it can and can't do?
It can do things reasonably well if you can give it a test harness to prove that it's correct. That's, I think, where the boundary often lies. Like, if I can help it test itself, and we can both agree on if this test works, it's probably good enough, then it can solve that problem. If it's open-ended, like design, right? Like, it will think of something different than me, and we can't, like, talk about it quite enough for me to ever get happy with like what it's trying to produce on the first round. In those cases, like I found the most effective thing that you can do is Claude has a way to enter plan mode where it lets you go back and forth and it asks you a lot of questions as you're asking questions, and then at the end it outputs a markdown document of exactly what it's going to do before it does it. You can edit that markdown document, go back and forth with it, and that document kind of acts as like a source of truth before it actually starts working on anything. So it's kind of like a pre-test step where you've both agreed on what it's supposed to do. I've certainly had cases where it just ignores that document after the fact and says, no, I'm going to go out and do it this other way instead. So it's not perfect, but stuff like that helps. Yeah, you got a question? Yeah.
Yeah, when you say learn the fundamentals, like to what extent do you mean that? Is
Yeah.
it sufficient to do one project in like databases or something? Or should you have taken a course in databases?
I think it depends on, if you're going to work in databases, then I think like certainly the course would be better, right? But you don't necessarily know what your entry-level job is going to be. I do think like just a broad overview of, different programming classes. Take a class that uses R, take a class that learns about uses SQL and databases, and like those are pretty good foundational knowledge to then transfer over to Python if that's what your team uses in your entry-level position. Doesn't mean you have to come in knowing everything about Python. Doesn't mean you have to know everything about databases in R. But like the ability to kind of critical think about how to solve a problem, either like using, I know this package exists and it seems like it solves the problem, and I could pull that in and maybe like read some documentation or start to ask Claude, using this package, how do you solve the problem, and direct it a little bit more, is a little bit where the fundamentals come in. Honestly, like the biggest thing that I think you get from, learning more R, learning more database stuff, learning more Python stuff is the ability to tell Claude no. Like the ability to say like, no, like that's not the route we want to go, and because I know that like that's going to lead to failure in some particular way. Like this is the route we actually want to go, and help it course correct. And it's hard to describe like, you get that from doing a course, like not necessarily. It certainly helps. Like I think repetitive repetition and experience like kind of help build that intuition, where just relying on the AI for everything will not. So, you go first. Yeah.
So like, how would this compare to, say, like, quote unquote, like an average person who is not in data science? Like, I think about like
Yeah.
the introduction of like the iPhone or the tablet.
Yeah.
Like, there's that learning curve of like everyone now knows how to use an iPhone and a tablet,
Right.
basically. Is it worth do you think it's worth for people, like the average person, to learn either how AI works, how to prompt AI, or maybe like basic computer science fundamentals, as you say?
They have different tools for different sets of people. So like Claude Code is very much for software engineers, data scientists. Even data scientists are a little borderline there. Programmers, I would say. Claude Cowork is like another kind of technology that they have at Anthropic, which is more of like a desktop app type thing where it pops up and kind of helps you with your day-to-day tasks. Like it can help you with email and stuff like that. And you can give it all kinds of other things to help connect in your life and use Claude with. I know that like our sales team is using Claude Cowork to help them generate sales reports and stuff. So like they're not programmers and they never will be, and I would never tell them to install Claude Code, but they do get a lot of value out of using like Claude Cowork instead. So I have not used that myself, so I can't give too much insight into how it works. But I do think that there are going to be a set of tools that developers use and a set of tools that like the general public uses. And I do think there will probably be that as well.
I always feel like there's a paradox in kind of the last thing that understanding it's important to learn how to use agentic tools, Claude Code, Codex, but then also to learn the fundamentals. And I feel like that's a little bit like giving Mickey early access to the magic hat.
It is, yeah.
Like, how do we, every senior engineer now, I feel like came up, writing code by hand, hitting bugs, going to Stack Overflow. It's not that they didn't copy code from other places, but they really had to like go figure out how to fit it into their use case or think about it and really interact with it in a way that, maybe that senior engineer at Google is doing now, but the junior is not.
Never experienced, right? Yeah.
And so it's like, it's great that Claude Code has tutoring tools and Positron Assistant can interact with you and teach you new things, but like, is that enough if we're not just getting into the trenches and literally writing it by hand ourselves?
Like there's some level of like, I just can't use the powerful thing, like where you just, if you have the privilege and the time to be able to go through and like learn it at a deeper level, I would encourage that if you can. Like I totally get if your job is just saying like, no, you have to get this thing by Thursday and like you don't have the time and Claude can help you do it, then that's what you have to do. And that will help you get through. But like, it's mainly for those cases of like, neither you nor AI can solve the problem, now what, right? Like, and a lot of times the